Welcome to Study Loop.
So the entropy change of air across the shock for upstream Mach numbers between zero point 0.5 and 1.5 is to be determined. So here certain assumptions are required that we have to take. First is that air is an ideal gas. Second, flow through the nozzle is steady. That is the first one. Second, it is one dimensional flow. And the next one that we have is isentropic before the shock. Okay, these are the assumptions that we have. Now, the properties of air are K equals to 1.4, R equals to 0.287 kilojoule per kg Kelvin, and Cp equals to 1.005 kilojoule upon kg Kelvin. So here, when we do the analysis, we see that the entropy change across a shock is to be determined. It is determined by S2 minus S1, and that is Cp ln T2 upon T1 minus R ln P2 upon P1. So where we have Ma2 equals to Ma1 square plus 2 upon K minus 1 upon 2 Ma1 square K upon K minus 1 the whole this. Also we'll get P2 upon P1 equals to 1 plus K Ma1 square upon 1 plus K Ma2 squared. And also one more formula, that is T2 upon T1 equals to 1 plus Ma1 square K minus 1 upon 2, 1 plus Ma2 square K minus 1 upon 2, that we have. Now the results for different values of Ma can be tabulated, and we get a tabular form in this way. We'll have 5 columns. One is for Ma1, second is for Ma2, third is for T2 upon T1, fourth is for P2 upon P1, and there's an entropy change. So we will see it for different values. So when we see for 0.5, it is 2.6458. This is 0.1250. This is 0.4375. This is 1 point minus 1.853. Then we have for 0.6, 0.7, 0.8, 0.9. So when we do all this, we are going to get the values 5031, 1.2731, 1.1154. Then we have for this is 0.2533, 0.4050. We have 0.5800, 0.7783, 0.6287, 0.7563, 0.8519, 0.9305. We will start here from minus 1.247, minus 0.828, minus 0.501, This is minus 0.231. Then when we see for MA1, if the value is 1, when it comes to 1, this also will be 1.000. Okay. Now this will also be 1.000 and this will be 0. So if you see, till here we have a negative value. We have a negative value for the entropy change. But now when we see the change, you will see the change here for 1.1, for 1.2, for 1.3, 1.4, okay, and for 1.5. So you will see the difference here, 0.9118, 0.8422, 0.7860, 0.7397, 0.7011, 1.0649, 1.1280, 1.909, 1.2547, 1.3230. Here we have 1.2450, 1.5133, 1.8050. Here we have 2.1200. Here we have 2.4583. So here if you see there is an positiveness, that is coming positive number 0003, 0.0021. Here we have 0.0061, 0.0124. Then here we have value. Here we have the value 0.0210. So if you see, in this case, the entropy change increases, but the others decrease at this stage. So that is how, what is the relation? So if you plot a graph. So now if you plot a graph for this case, if this is for S21, the entropy change, and for the MA, you will see the graph to be in this form. Okay, understood?